The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
This is the container. What happens in this is biogas gets produced in here. It goes out the tube through this set of tubing and into this container to hold it. This is just clamped off, and when you unclamp it, you should be able to get biogas from this and light it. This has only been going for a week and a half or so, so it may be producing biogas. If you if you play with this, you feel some suction on there, but I don't know how much gas this one produced yet. I've been keeping it upstairs because upstairs is way warmer than downstairs in D-Lab, so yeah. When we're done with ours, we're gonna put them upstairs as well. The base looks something like this. So the first thing we're gonna have to do is measure out 12 inches by 7 inches from here, and each of your groups of 3 is gonna have to cut one of these out. So let's start by measuring it. I'm gonna run up and grab a completed one that I made a week and a half ago, so you guys can see. Should probably go the other way so we can fit. So you want to measure 2 inches from here and 3 1/4 inch, or 3 1/2 inches from here.
That's good. And then you stick it on there. Where's the mini guy? Yeah, it's on there.
What's your favorite? You're gonna have to leave one.
Basically, your only ingredient in the biogas digester is this slurry. So for your container, for us, we're gonna fill this 3/4 full, and the ratio of water to human, animal, or vegetable waste is 3 parts water to 1 part manure. And so that is like one thing that might make. Basically, that's a factor you'll want to consider. Like, we were thinking of putting in a biogas digester in where I was in Tanzania, but their water supply dries up a few months a year, which meant that just to get water for their family, they would have to either pay more or walk a really far distance. So something like this would be a lower priority, and there's a good chance that it would dry up and stop working, and after that, it's really hard to get it going again. So the 3 things that are really important for a biogas system are a good supply of the manure, having a hot enough temperature, and having a good supply of water. So if you have those 3 things, it's a really good solution. But if one is missing, then it will be tricky. So, someone want to dig in? Ooh, it's right.
Oh, okay. That's smart.
Less terrifying than the
introduction.
Yeah.
Oh, it's nice and dry.
So kind.
Are we doing more than one?
Yeah, we're doing 2 containers. And this is the
Cold or hot
slurry
water?
that you'll put into the biodigester.
Lukewarm.
So basically, you put this in an anaerobic environment.
Is that good enough? A little more? Less?
No, we only want 3/4 full. So you could do a tiny bit more. Yeah.
Is that good?
Yeah.
Nails were stuck to my jeans. You're like, this is something I can show that.
Do I need to clamp it down and do that?
Are we supposed to touch this? I'm just gonna touch it.
We need them like this.
And then we need to hot glue the bottom too.
Oh, really?
Another we need another piece like that, right? That goes.
This actually fits surprisingly well.
Yeah.
I'm pretty impressed with ours.
Yeah. So I think this is where the other tubing, the clear tubing, is supposed to go.
Yeah.
Like through
We
here,
need
right?
to make sure this is sealed first
Yeah.
for whatever.
Okay, so we need another piece of tubing. And hot glue down the bottom to the.
I feel like the white tube should be smaller because it should be floating.
Hmm?
I feel like the tube should be less tall because it's kind of in the way right now. Okay.
Yay.
Good work, team.
So one thing that you can do with the heat sealer is make a SODIS bag. So this is used for solar disinfection of water. So it's one way that you can purify water. What you do is you can fill any basically clear plastic container with water, and then you leave it out in the sun for about 6 hours or so, and it will kill the bacteria that's in it. So you might still need to filter it if it's turbid, but as one step, that's actually pretty effective. So actually a D-Lab alum, MIT alum called Sean Frayne, his company is called Haddock, and they produce these. So like an alternative would be to just fill maybe a plastic water bottle, or this is one, but it's not, it uses more material than this, so it'd be more expensive, and it's not super easy to fill, like if you're pouring water from something. So what he came up with is just this bag. Basically you can fill the water here, so it'll just go in.
Like 2 compartments.
Yeah, so there's a smaller bag here that has a hole in it. We actually, in the last session, spent a while like figuring out exactly how the different parts work, because it's a pretty clever design. And then, so basically you fold it down, and then the water is sealed in here. And then after your 6 hours, you can just pour it out pretty easily. So it's a pretty clever design, and this is something that you can make in the field too. Like every time, I think Amy brings a heat sealer on most of her trips, because there are just a lot of useful things that you can make. I worked on a chlorine dispenser for my D-Lab design project, and we did something kind of like this, where it's like this, but it's just a one-way valve, so the idea isn't that you'll be able to get it out afterwards. This was a really low-cost way for us to like store the chlorine and then keep people from getting it out, because we didn't want anyone to be able to siphon it out or tamper or anything like that. Another thing you can do, so this is a drip irrigation kit, and the way this works is you would fill it up with water, and then you'd have a tube coming out, and from that tube are many little straws, and you can direct a small amount of water straight to your crops, so it's a much more effective way of irrigating, and it uses a lot less water. Someone who I worked with in Tanzania named Bernard, he has actually made his own heat sealing machines like this, and he can make the tubes that would come out of this just from a heat sealer and locally available plastic, rather than having to buy that or import it. Another thing you can do to seal something like this, if you have male and female pieces like this, you can take some sort of rubber and make a washer, and what you do is have a rubber washer layer, then a plastic or metal washer. And then you could have your plastic bag, like basically this piece is a way to, and then on the other side you'd have another rubber washer and plastic washer, and then you could have a sealed connection there. Just as an example of something else you could do, like a way to connect a bag like this to something else. So the things we have that you can try out. So this machine and this one work the same way. It's cool to the touch, but basically when you push it down, you'll see a light go on and it makes a click. And then it just melts the plastic. And you can vary the heat level here. So in some cases, like for the SODIS bag like this, you might have some seals where you want it to go through like 2 bags but not 3 or something like that. So you can adjust the level so that it will only melt through 2 and leave the other untouched. And yeah. That's like the sweetest thing. It's like quite
Yeah. So are you saying that like? Okay. Yeah. So are you saying that like this part of it?
I know I'm melting. So you can tell kind of. So this edge of the bag is this whole thing.
Yeah.
Like this.
Yeah.
Yeah.
Okay.
And then but this edge goes to the little.
To the
bag.
small, yeah. And so when I do this, then
Then it's
essentially
sealed.
what happens is that I prevent water from coming in from here, because when water hits here, this part is stuck there, and
Wait,
yeah.
so the other side of this tube is one side of the small bag?
The other side of this, yeah, this goes into the bag.